Welcome back for the next session, viewers. Hope you had revised whatever we have learnt earlier about the trigonometric ratios of some specific angles and the complementary relationship and also the basic trigonometrical ratios. So after this session, once again we'll have a quick recap of all that we studied so far, and then we will move on to the problems, which is very, very, very important. Okay. Now, let us see the basic three identities of trigonometry in this session. See, in trigonometry, we can derive a number of identities. So that is given as proving sums in the exercises. In order to prove those results, which are also identities, the fundamental three identities are very, very important. So you have to know the identities, but also you should know how to derive them also. So both are very important. So we will derive these identities one by one, and you have to remember them very correctly. You have to apply these identities in order to derive other identities. Okay, is that clear to you? Now, the very first one being sine square theta plus cos square theta is equal to 1. This is the first identity. So what have we to do? As usual, we are going to draw a right triangle. I want all of you to do with me. So, draw a right triangle with B as the right angle. Ready? Hope you are doing it. So, take your notebooks and draw a right triangle and then mark the right angle as B and get ready. Yes? Okay. Now, tell me, what is theta? Theta is angle C. So, theta you also mark in your notebook. Theta is angle C. Correct? We can even call that as C itself. Angle C itself. But I want you to be more familiar with the symbol. So, I am insisting that you should use the letter theta for denoting the angle. Correct? Shall we go further? Ready all of you? Yes. The notebooks you have drawn. Now in this triangle, what is sine theta, children? Sine theta, go by the definition and tell me, what is sine theta? Sine theta is opposite by hypotenuse. What is opposite here? With respect to theta, the opposite side is AB. So hypotenuse is AC. So we have got AB divided by AC. Therefore, what is sine square theta? It is AB square divided by AC square. Have you all noted down in your notebook? Written down? You have to write down these identities. Next, cos theta. For the same triangle, what is cos theta? It is adjacent by hypotenuse. So adjacent here is BC. So I am writing this as BC divided by AC. Therefore, cos square theta is what? BC square divided by AC square. Have you all written down this in your notebook? Yes. Now add both. If you add both, what do you get in the left hand side? Sine square theta plus cos square theta equal to AB square divided by AC square plus BC square divided by AC square. Now combine, both have the common denominator as AC square. Work out in your notebook in the same manner. So AC square as the common denominator, I can write AB square plus BC square. Now tell me, what is AB square plus BC square? Because it's a right triangle. Apply Pythagoras theorem. This is nothing but AC square. So this AB square plus BC square can be replaced as AC square by AC square, which is equal to 1. Therefore, the first identity is proved. So sin square theta plus cos square theta equal to 1. The first identity is proved. Is that clear to all of you? Very clear to all of you? Now, next identity we are going to, for the same triangle, we are going to derive the second identity. Second identity is 1 plus tan square theta is equal to secant square theta. That is the second identity. Now, here, just like how you got these ratios, in the same way you have to get for here also. Now, I am going to write 1 plus, what is tan theta in this? AB by BC. Is there any doubt? Opposite by adjacent. So what is square value of that? AB square plus BC square. Is there any doubt in this? Shall we proceed? Yes. So it is AB square plus by BC square. Now take this BC square as the common denominator and we get BC square plus AB square divided by BC square. Can you tell me what is BC square plus AB square? Again, it is the Pythagorean relationship for the triangle ABC, which is obviously equal to the hypotenuse square. So that is equal to AC square divided by BC square. Now look at your triangle and tell me what is AC by BC? Hypotenuse divided by adjacent. Who is ready with the answer? Hypotenuse divided by adjacent is nothing but secant, isn't it? Secant theta. Therefore, AC square by BC square is secant square theta. Therefore, which is equal to secant square theta. Therefore, 1 plus tan square theta is equal to secant square theta. This is identity number 2, that is proved. Are you ready? Is that clear? So first identity, only thing is we have to take the triangle ABC and we have to get the ratios. That's it. And we have to add up. You will get this relationship. Is that clear to all of you? Now come back to the third identity. Third identity is 1 plus cos square theta is equal to cosecant square theta. How do we prove it? So 1 cos square theta from the same right triangle. What is cot theta? Adjacent divided by opposite. So adjacent is BC, opposite is AB. Therefore, when you square it, you will get BC square divided by AB square. Now tell me, if you simplify this, what do you get? AB square for the denominator and this is AB square plus BC square. Now I don't have to say it is AB square plus BC square is AC square. Therefore, you get this value as AC square by AB square. Now tell me what is AC square divided by AB square? It is nothing but hypotenuse by opposite the whole square. So hypotenuse by opposite is obviously, yes, cosecant. So therefore this is cosecant square theta. That is cosecant square theta. When you are writing cosecant square theta, the square symbol should be on top of C, not on top of theta. It should be written properly. And again you please make it very sure. Cosecant square theta is cosecant theta into cosecant theta. It is not that cosecant into theta square. Please, you have to make these observations very carefully. Cosecant square is cosecant theta the whole square. So that is we are denoting by this way of writing. Okay. Therefore, the third identity is 1 plus cos square theta is equal to cosecant square theta is verified, is proved. So these three identities are very important in trigonometrical calculations. We will be going through problems in the next sessions. Next following sessions, we will be continuously working out the problems that are given in the exercise as per NCERT textbook. At that time, we will have to use this identity very commonly. We have, with this, the help of these three identities, we will be proving many identities which is going to come in the following session. Thank you, children. Thank you.